Last question, question 9. It's the 9 marker, it's the long one, and while reading the question, you need to already plan your answer out a little bit. Human activity and bacteria play a vital role in making nitrogen available to increase the yield of crops. Explain the ways that human activity and bacterial action can influence nitrogen availability. So those 3 words come again: human activity, bacterial action, and nitrogen availability. And then, as a last one, as an addition, negative impacts this may have on the environment. So if you were to split this apart, what do humans do to make nitrogen available? What do bacteria do to make nitrogen available? And what is it potentially that actually has a negative impact on the environment? And if you're already kind of think in your head, oh, that's the eutrophication question, awesome. And actually that part was not done badly at all. That was not done badly at all. The first few bits I kind of thought, hold on a second, you can do better. You really can do better. And some of this has just been forgotten. And I'm a little bit cross about the lack of the word nitrate. That's something that really got to me, because it's avoiding using the word nitrate, which means you need to use the word nitrate. Human activity, that basically means, what does the farmer do? What does the farmer do? In order to maybe do things directly or to encourage bacteria to do the whole thing directly. I'm going to twist that mark scheme around a little bit. I'm going to show it to you in a second anyway, but I don't like the way that the mark scheme is laid out at all. The first thing, fertilizers. It's an artificial source of nitrates, okay? And they're generally quite slow release, but much faster still than actually adding manure, which is something that farmers do. This is again nitrates, however not directly, because you need bacteria to go with that. That one here you need bacteria to go with, because manure does not directly have nitrates. You'll need to first of all go through the literally the nitrification cycle, so the nitrosomonas into nitrites and the nitrobacter into the nitrates. But ultimately we have got a really slow release into nitrates. Here we go, we've got that, and that is now via bacteria. Okay, so the manure doesn't directly get changed in there. One person has lovingly given me that lightning is happening. I don't really think human activity causes lightning to that extent, so thank you. It would technically be true, but not quite. I have had a description of the Haber process here for the nitrates. Thank you. It is as much as you're describing it, but it doesn't give... other than saying it's an inorganic form of fertilizer, it still doesn't mean that I can't add much there. The only thing you could do from there, if you're describing Haber, is that actually in the process, because it's an industrial process, you're actually producing carbon dioxide gas as a sidekick, which then means your negative impacts on the environment, you can from there say that is a global warming thing. Global warming. Okay, that's the only extra mark you can get there through the Haber process as a little extra addition. I need to see much of that nitrogen cycle there. What do farmers do to encourage the nitrogen cycle? Farmers plough. The oldest possible farming techniques. Why? You aerate. What is it that gets into the soil when you aerate? You're going to get oxygen into the soil. You're going to get nitrogen into the soil, okay? Nitrogen is somewhat unreactive. It doesn't do much, okay? The only thing you could do with the nitrogen is that you have got nitrogen fixers, nitrogen fixing bacteria, in which case you want to do your rhizobium, wait, I'm spelling that wrong, rhizobium, and your, what are the other ones called? The other one, the other nitrogen fix is going to come back to me, azotobacter. Okay, that's that one. The other thing is for the oxygen that you are encouraging aerobic bacteria. Okay, if oxygen is available, oh, These ones here are aerobes. You want to encourage them. The bacteria that actually change manure over, so the nitrosomonas and the nitrobacter, which change manure into nitrates. So the end product here, both ways around, is always nitrates. These ones are aerobes, so getting oxygen into the soil. Great idea, because you're encouraging all the right bacteria. What you could say, if you didn't plough, if there's not much oxygen, you are going to get your pseudomonas. They're anaerobes, and they change nitrates into atmospheric nitrogen gas, where it's completely pointless and useless to the plant. Plants can only take in nitrates from the soil. So yes, that they can produce their own proteins and nucleic acids, wonderful, but that's not what the question is asked. Again, I've got people giving me beautifully what an earlier question in the test is asked about, but not actually this particular question. What else can you add? What else can farmers do? Farmers can plant a cover crop, something like clover, something that has got, legumes they're called as well, something that's got the root nodules, where you actually have the rhizobium bacteria in those root nodules to encourage nitrogen being turned into nitrate directly. So that is something else that farmers could be doing. This is an overlap between nitrogen cycle and human activity, encouraging the nitrogen cycle. Last but not least, your environmental impact question. You will need to speak about eutrophication. Whichever way around you do that, farmers putting fertilizers and manure onto the field, which are both fertilizers, if they're washed off into rivers, lakes, waterways, you have got the overgrowth at the surface, you've got lack of light further down, and therefore the whole decomposition starting as everything dies underneath, oxygen's used up, and your entire lake or riverbed is ending up dead. So let's look at the mark scheme. It is literally the same thing, just through different words. So what do farmers do? They're adding manure, which is dead and decaying material. This is a slow release of nitrogen. Has to be broken down first before we get into the nitrates. So the in-between steps to ammonium after the nitrosomonas and then the nitrobacter. All those in-between steps have not always been there. Farmers can add fertilizers, which are soluble, so they're a bit quicker in uptake. Actually, I should change that on mine here. I did say they're slow, but not as slow. The manure is very, very slow. I should maybe change that one to faster. And they're also, because they're soluble, they're more likely to wash into rivers and cause eutrophication. Manure does the same thing, but not as quickly, because it needs to go through the different bacteria first to actually be there. This is a faster way to improve soil fertility. Okay, the cover crop, the legumes, the planting clover out, or leaving a field empty. That is another thing you could have done, the crop rotation, that you're leaving a field unused. Somebody has been beautiful about the crop rotation, because different minerals are being used. Yes, true, but this one is specifically about nitrates, and all plants use nitrates. So the crop rotation argument is only a valid one if you're including the year that you're leaving a field empty and nothing grows on it. Okay, so the leguminous legume plants with the rhizobium in the root nodules to literally fix the atmospheric nitrogen into nitrates. The ploughing, I forgot the drainage element, that literally it's not only airing, but actually if you have water flowing off, digging drainage channels around the edge of your field as well increases the aerobic conditions, which then discourages the pseudomonas or denitrification. Then, what have I forgotten? Soil fertility, and it'll just be ploughed under. The environmental impact here with eutrophication, either you've worded it or you've described it well. That's absolutely fine to do it that way around. And that last one here, that was the idea that you could say actually producing artificial fertilizer adds carbon dioxide, as it's like any industrial process producing waste gases, and therefore the global warming is a bit of a thought process here. Right, please apologise my many mistakes that I made in talking through this entire thing. I still hope it was valuable and hope my time was well spent on getting this ready for you. You take care and have a wonderful Christmas.